So, we get back, and today we will talk about agentic AI and the databases. Yeah, so and why agents need the strict guardrails, and especially for memory. Yeah, so the first thing that people usually do, and the internet is full of these guides, is just to build your knowledge graph with the LLM. And it doesn't matter the language, but usually you just feed randomly the messages, and without any kind of ontology, you just start collecting the data, and you're getting quite good results at the beginning. But in a couple of weeks of usage, you just understand that your data is completely random and look more and more like garbage. Actually, it was our observation at King when we just started building the memory, and we just realized that we need ontology. Because without ontology, and it doesn't work. But we need the ontology in a form of guardrails and constraints that say what's possible in a memory. And from another side, we need the ontology to say not just what's possible, but what's really matter. And it's a huge part that nowadays um, mm, we have the OVL, Shackle, and all other things that focus in a RDF world, how to do it. But still, it's not giving all the capabilities and possibilities uh, to construct something really complex and make it stricter. I using the OVAL for a long time, and OVAL have some amazing things like rules, descriptive logic, and all of the stuff. It's allow the reasoning, it's allow many things that property graphs unfortunately doesn't have. But still, it's hard to express super strict guardrails. Sometimes you need to combine different tools to, for example, Shackle and all to achieve it. I know that it's a form of religion. Every time when you go to the RDF folks and say that the semantic stack is not capable to do something, they will say that you're using it wrong. And right now, with the newer version of RDF, we could do everything. And I completely agree. We could do it. The problem is that it's getting more clunky and complex. And if it's clunky and complex for people, probably it will be a bit clunky and complex, not only for people, but for the labs. And how to combine the strict guardrails with the possibility to express what's important was my big question. And how we usually do it in software, and especially in some more advanced languages, we have types. We design the classes, we design the hierarchies, we design the inheritance and all of the things. So we express our logic and constraint as a types. And if you go to ultimate extent, in some point, you will be the religious guy who using Haskell or maybe Rust, where you have extremely powerful type systems. And OCaml, for example, have yet another amazing type system. And yeah, and it's already Sorry for that. It's already extremely powerful. But you could go even further. You could get the languages that allow you to blend the types with the values and allow you to encode even the logic to the value to the type. For example, you could create a type that say that you have the list of 3 items in a type level, or you could describe some logical constraints directly to the type and code your logic and what's important to happen and what kind of shape of the data you want to capture. And this kind of languages work with the dependent types, and dependency it's between the type and value. So it's a mind-blowing mathematics of the dependent types, especially cubical types and all the thing that force you to think like the mathematician. But the biggest discovery that types that we have in programming actually came from the different branch of the mathematics. So they came from the logic. So the type is the logical construct, and the types just begins as a revolution in mathematics when the Russell discover that sets are not enough to describe our world. So the types are the form of logic that change the fundamentals of the mathematics. And if it's change the fundamental of mathematics and allow us to describe the world around us, it's actually allow us to describe what's matter for the agents, memories, and LLMs because it's flexible enough. And if we have the better constraints, the LLMs will work way much better because the stricter you have the constraints, the better guardrails you get. And we even see it in a vibe coding space that if you have some strict language with the static types, and especially if you have the language that could do something in one particular way, it will eat less tokens and give you the result much faster because we have the concrete guardrails. And yeah, Rust is much better for the vibe coding than the JavaScript, or at least it's much cheaper. And it's getting better and better. At the beginning, it was some problems with Rust because of the training data, but right now, the modern coding, it's extremely cool. And if we're talking about the types, how we could bring the types to our data storage? For sure, we could use the software, build the layer on top, and then we have this classical headache that called the object relational impedance. Yeah, so then usually as a developer we use some ORM tools that try to close this impedance, and we encode the part of the constraints in a database, another part of the constraints in a code, and then get the depression because to synchronize all the things is extremely hard. But what if we could use the same types and even functions and programmability in our databases? And I'm not talking about document databases that some in some point try to cross this border, but they sacrifice the schema, and they made this border works much better for the languages like JavaScript. Yeah. I talking about the database that's getting my attention for more than 2 years actually. I talking about the type DB because the type DB actually get the dependent type theory seriously and make it as a core of the database. So everything is typed. So you have the strict type definition that define the schema. Your query is yet another form of type that typed. Types are everywhere. And together with types, you even get the possibility to write the functions that you could use in a queries, and functions are also typed. So it's some kind of dream that right now you have your tools that, or at least the concepts that you use in a programming for decades, just inside your database. But what's more important, you have extremely strict, understandable, and well-defined constraints. And right now, you could really say what's matter and how it should look like. Because even with the graph databases like Ladybug, it's not always possible because Ladybug, why I really like the Ladybug as a property graph database, that you have the schema. And right now, even Neo4j start following the idea that it could not have the random graph. We could use the schema, but in a graphs, you could describe the shape of node with all the properties. It's not a problem. You could describe what possible connections between the two nodes you could have. It's good, but you have no ability to describe the shape of the subgraph. Yeah, so we could say that parent and child could have the relation, but we could not say that child should have only two parents. So we could just make the query that will validate the state, and then we just move the constraints somewhere on the application layer and all of the things. But in a type DB, you could just design the type that you have the special kind of relation, and this special kind of relation have the particular rules and fix precisely um, this constraint. And TypeDB was scary to me at the beginning because they use TypeQL, so it's completely different query language. It's completely new paradigm, but this paradigm really good because not just this the strictness, but also it's not force you to learn all this crazy mathematics. It's give you quite simple concept of para, this polymorphic entity relation attributes, and it's a really good modeling framework, quite visual one that allows you to design your data quite easily. But the beauty of it that you could feed this to the LLM. I already tried a couple of times. Teach the LLM the type DB and use the type DB constraint as extraction rules. And also, you don't need a special evaluation framework because you already have your database that could validate the data that you try to store. And if something will happen, you will get the error and you could retrofit this back to the LLM. So together with the construction rules, you also get the evaluation agent. And mentally, it's if you are the developers, it's quite close to what you already get to use. And what I did, I get my Ladybug book and get it to the next level because then I try to get all my concepts that I have with the semantic space time metagraphs and all of the things and try to encode them back to the TypeDB, and it works. But another observation that it works to some extent, but TypeDB is more close world, so it's more stricter database mm, that force you to think in advance what's possible and in property graphs, and because it's weaker constraints, it's more friendly to open world ideas, that it's more extendable, because when you want to extend the TypeDB, you need to think about what's possible in your current types and extend the types. But on the same time, as I said, the stricter constraint and the closed world design, it's a better guardrails for your agents. And I wrote the book. I wrote a book about the TimeDB, and I express all my work, maybe not so extendable the memory, that explain how we could use all these concepts. And if you want to learn something new, and if you want to have the stricter guardrails for your agentic AI, for sure, uh, give it a try. Buy the book, read it, and let me know what you think about